IETF research group. We are Börje Ullmann, Dave Aran, and my name is Dirk Kutscher. We are your chairs. And next slide, please. If you haven't seen it, this is the IETF IPR policy. This is the policy by which we operate. So basically it says inform the group about IPR that you are aware of, that is mentioned, referenced in any contribution in these meetings. Next slide, please. That's our usual admin information. So we have a mailing list, we have a wiki, and you will find all the material from previous meetings referenced there. So very important, so we need a note taker for every meeting. So quite often we have say interesting discussions, and we really need to capture them for those people who cannot make it to the meetings. So we are relying on volunteers for note taking. So we now asking you, is anyone able to take notes today?
I can do it.
Great, thank you very much. Okay, so we normally use an Etherpad, so it's also linked from the wiki page and or in these share slides.
Could we ask for someone to take over the note-taking while Prakash is doing his...
Right. So there's one presentation by Prakash where he cannot take notes. And if somebody just, could help out just recording the question and answers for that presentation.
Please.
On the Etherpad. It's not a big job. Thank you.
Thank you.
All right. Next slide, please. Okay, so we have quite a busy agenda, so let's try to stick to the time. So we're going to start off in a minute with a block of IoT, ICN presentations and some discussion. So we have Ravi on ICN in 3D mobile network architecture. We have Prakash on ICN LTE. We have Akbar on ICN deployment guidelines. We have Matsusono-san on network coding, and Duan Shihui on multi-service tech today. Right. Just a couple of updates. So we have a few documents. So if you're new to this, we have a few documents that we call research group documents. So these are the ones that are under change control by this group. And so these are normally documents that we kind of deem interesting, important enough that we want to do a publication RC at some point. So the CCNX specifications have been worked on and presented here quite a bit. And they had already been in the IRSG review where we got some comments. Those have been addressed. And so we are now ready to kind of do the next step and move forward towards publication. That's, I think, real good information for people who are building ICN systems. So these are basically the core specifications for CCNX. We also have a document that describes ICN terminology. So we had a presentation on this on our Sunday interim meeting, which I'm going to talk about in a minute. And this is also at a relatively advanced state. And so we would also like to adopt this as a group item. So we did an earlier poll on the main list and also on Sunday, and people are generally supportive. So we're going to confirm this once more on the main list after the meeting. Next slide. And okay. Okay, so just a quick summary of our Sunday interim. So we had a full day meeting on Sunday. You can find all the slides in the data tracker. So there's one specification that we call, so on technology we call FLIC, so file-like ICN collection. That's a kind of a manifest type of technology. This is also so it has been around for some time. It's mostly stable. This is something where we would like more people to have a look at, and maybe also hear a bit more about experimentation experience. So check this out. We had a presentation on a 802.15.4 ICN adaptation layer, so ICN on a specific layer 2. So think like a 6LoWPAN like. So that's yeah, also of course interesting for IoT. This led to an interesting discussion about compression of ICN. So this the group of people working on this are thinking about ICN, so CCN light compression in that case, and we discussed a little bit whether that could be generalized or not. We had a presentation on contrace, so a trace route-like feature where you can discover path, RTT, and so on. So this is most likely going to be merged with another trace route-like proposal, so NDN ICN trace route. Next slide. And then we had a, say, larger block of name solution oriented presentations and discussions. So Jungha from ETRI kind of explained their implementation and their current system, so what they are doing. And then we had some discussion about, you know, so what is the, say, purpose of name solution, how would it fit into the system, and so on. So if you're interested in that, check out the slides, but also I think the notes from the meeting should be quite interesting in that case. All right. Yes.
Just to interject, this is a major work area for us. We've been dancing around this area since probably the very beginning of the ICNRG 4 years ago. There's been a whole lot of talking, but now we actually have some working, and people, you know, the ETRI folks and other people actually building things that we can bring back in here, evaluate, and start figuring out just where name resolution fits in the overall system, what we use it for, and things like that. So we expect this is going to be a major topic, just continuously going forward over the next, you know, year or two. So if you have any interest in this particular subject area, we could really use, you know, a lot of brain power applied to these problems. So if you have any interest in there, we're quite receptive to people building alternative systems, doing reproducible results on evaluating the systems that are being built, and also figuring out exactly how the integration with routing happens, which seems to be one of the trickiest parts. So yeah, let's try and get progress here.
Right, and so this is most likely going to be really, you know, security specific. So that's going to be like a major. So security is going to play a major role in this discussion. Okay, then so Nacho explained a little bit about so how Kafka, so one Apache messaging framework works like, and what the relationship to ICN, looks like. And so that's actually an interesting discussion. So I mean, there are several of these, say, application layer messaging and stream processing frameworks, and so they often do similar things like ICN does on the network layer, but just few layers above. So message routing, potentially also some data-oriented communication and processing. And so there's, I mean, so Kafka is one specific system, but there are also many others. So also in the IoT world, for example. So this could be something we might want to look at in the future. And then, so finally, Lisha presented some ideas, and yeah, so early results on AR, VR work for ICN. All right, so so let's start this meeting now with our IoT discussion, and I think Börje is going to kick it off with some notes on IoT for ICN.
Okay, so I'm Börje Jonman, and this is work done together with Anders Lindgren and Bengt Dahlgren. And we have been thinking about IoT naming, and here are some of those reflections. So, first about this presentation, this is what we're trying to do is to understand the requirements, to see what tools we have and what trade-offs can be made when you do IoT naming. We still haven't gotten to any conclusions on what are the right things and so on, so that this is sort of trying to kick off work in this group that we think needs to be done. So this is something for you to think about. It's really difficult when you don't see the slides. This one doesn't work. Some dimension of this IoT naming is that we think, or you could have encode application semantics in the name. You could have routability information there. You can have names that are persistent, and time could be reflected in the name. And you might want all of these, which might be difficult. Another aspect of how to name things is when you have hierarchical names, there are many different ways to do it. So maybe this will start working now. Yeah, great. Good, we have some technician here. I tried it earlier and didn't manage. Okay, so in the paper presented at the ECM conference, I think this were illustrative example is that the same object can be published under multiple names, and that is not always that convenient for caching and other reasons. So the conclusion from this is that it's unlikely to find a naming convention that fits all needs. So what can we then do? We can, of course, have a large number of names for each data object that you can optimize them for persistency, uniqueness, work well with time series, routability, manageability, and so on. And in that case, do we need a way to map and translate between these names? Do you want to be able to say that these are the same in the ICN router and you can cache just one of them and just have mapping between them? Let's dig down a bit into the time thing, because this is really one of the most important things for IoT data, I think. I haven't been able to come up with any type of IoT data that's not in some way time dependent. Maybe there are, but most of them do rely on time as one key thing for it. A lot of IoT data also come in the form of time series. You measure things continuously over time. Then also you want to access these different data. You want to be able to get the most current version of it, or you also want to be able to access historical data. And it would be good to be able to do that without having to download the full series and search it, but you should actually be able to ask directly for a specific historical value. And caching shouldn't screw things up, so when you want the most current value, you get the value that was the most current in the cache that is cached, but there is somewhere in the network it's a more current value. So how should the time be reflected in the name of the IoT objects? That's one thing that is an important question. And if you want to do that, there are different ways to do it. One is that you have sequence number in the name. Another one is that you have actual timestamps in the name, or you don't reflect it in the name, just have the time in the object data or in some metadata. All of these have different trade-offs. If you use sequence number, it's easy to know that normally you don't get holes. You know there is always 1, 2, 3, and so on. But on the other hand, if you want a value that's from 12 o'clock yesterday, you have to figure out what sequence number to ask for in that case. There are other problems also. For absolute time, it's easy to know to find that type of value at a specific time. On the other hand, depending on what resolution you have and if they are generated with fixed interval, if they're not, it might be difficult to know which values actually do exist. So, yeah, these are, as I said, non-trivial things that we need to discuss and see what are the best ways to do it. And if you want to have it represented, the same data represented with multiple names, if that's the way to go. And then also, when you have time series, and those won't be perfect. Like if you have the temperature in this room generated by a number of sensors, they might not be fully synchronized. So how do you then know that which are the same values? Maybe you don't care, you just want the temperature here. Now, but which one should you pick? Also, you will have sensor devices restarting, and if they use sequence number to generate the sequence numbering might restart, and then you have to take care of that and be able to resynchronize these things. So we need some method of mapping these things, these time series that might be off sync. You also might have things that start when they don't have any time to synchronize, so they have some relative time they use until they can sync with the rest of the network. Another issue is then somebody generates all these things and they have to have some mechanism for generating the name, and you also need a way to find out what names you can ask for. And having these multiple devices generating data for possibly the same, or values for the same, like temperature, this room, you need to, at the same time, you should realize they are the same. You should also be able to have different names for them to be able to differentiate which one generated which. So you want to have some prefix for this, and these prefixes could either be, the devices could get it from some registration service, or they could create something themselves that is unique enough so that will work out. And then to find out what values there are, you could have service registers or use general search services, or just getting the name from someone. So, and if we go down the directory service thing, we need to have a directory service that is trustable, scalable, and you should also be able to find it. This is a bit tying into the discussion we had on Sunday on NRSs, which is one such possibility. And this way, to make it scalable, one way to do that would be to have them, that each publisher operates their name resolution service for the object they publish under a domain name or similar. If you think having routes for all publisher wouldn't scale, one idea would be that you could aggregate it under ISP, like ICN service providers, and then you would get down that. And you could have something like NRS as a dedicated name so you know what you should ask for. Also, I can mention that Anders just put a published draft on where they have done some work in OMA on how registration for these things could be done. So that's something you might want to look at also. Yeah. And then to find a specific value, you need a way to ask for the most current, to find it in a sequence. As I said, if you have sequence number, you need a way to map real time to the sequence number. That could be in some metadata, or you could be a way to ask this NRS what is the algorithm to map between sequence number and real time. Then we have this classic example of you want to know the temperature in this room, but you don't know what any name to ask for. How do you find that? Not sure.
Right, not just all Spark. Oh, sorry, LinkedIn. So used to saying that. Especially at these microphones.
Series mapping.
Yeah, it's the microphone context here at IETF. I'm not going to try to be rude, but I love spending time at IETF and these meetings, and I feel that this is something we've repeated 1,000 times. So without being rude, what is the point? Didn't we have we could have this presentation 3 years ago, right? We have the same questions. Is there like a new question or a new proposal? Or is it just to inform the new crowd that maybe hasn't come to ICNRG?
The idea with this is to not have this again and again. So this is initial. The next step would be to write a draft on this and get it documented. That's the idea.
All right. So the proposal is we should write a draft summarizing these points that hopefully some of you would agree that we've discussed in the past with kind of the same questions. I don't think we have like any new answers right now, right? Or
no, the next step will be to try to generate the answer so we agree on that and not end up with a lot of divergent solutions.
Okay.
Yeah. So as I said, this is basically a set of questions and set of things we would like to formalize and get done. So yeah.
So Borje, just this question of multiple names for the same data.
Yes.
Right. One of the interesting questions is what does it mean to be the same data? Right.
Exactly.
Is it the same bits or is it the same application semantics? So I think different ICN architectures, independent of naming, would have different answers to that question. So for example, the answer in the CCN architecture is relatively straightforward, right? Which is it's exactly the same nameless objects, but you have a different manifest for each name you want to express that under. Have people actually gone and evaluated that as what the pros and cons of that approach to alternative naming is? I mean, at least one of the architectures has alternative names for the same data built in as an architectural feature.
Yeah.
Okay. All right.
All right, just to make discussions live, not just all this LinkedIn. So what do we use names for? In this case, I think we had a discussion that maybe at one of our first actual seminars, and I'm sure it's been had in more than just computer science for a long time. And in this case, we use them for identifying data, and at least in the CCNX case, we chose kind of self-certifying hash names as kind of the base of much of our low-level naming. Any other naming that we have is just ways to organize data, or for that matter, attribute some, certify some entity saying this data may be named or organized or called this as well within that context of security. So we do have multiple names at the high level, but at the low level, the data we just define by hash.
Mm.
This could also be true for any type of naming referring to that hash, whether it's indexing or attributes or any other type that may or may not associate one-to-one or n-to-one or one-to-n, or who knows how many ways we have to look at the data. From this perspective, in one of your earlier slides, what you had a talk, you talked about time and whether we use sequence or absolute time or something. It is once again just ways to access the data in some index organized way. And what the data actually is may be part of that. So from this perspective, let me rephrase the question. Is time part of the name or part of the data, or both?
Yeah.
So if so, then whether it's inside or outside or organized, it's just a way to get to the data. Eventually, at least from a CNX perspective, the piece of data, the datum, the unique atom would be whatever blob is hashed, and we attribute anything we want to the hash. Everything else is just associations of other data with the data. And that sounds kind of redundant. And then eventually some keys certifying and saying, yes, I agree.
Yeah, I think the point we're trying to make here is that if you just do this for one specific application, you can do it any way you like. Doesn't matter. You just do it that way. The thing is, we want to have some type of convention or agreement that go cross applications. So when you want to build something that integrate data from a lot of different sensor domains, you don't have to deal with numerous different ways of doing this.
All right, so this one is easy because so I live this day to day. So like I move data around, and it is very important to us to structure the data such that if the use that we have for that data changes, we can still use it. So in this perspective, all data we have and we move around comes from some form of schema that we carefully make sure that it evolves in a forwards and backwards compatible way. So whenever something changes, in the processing side, we can do something with the data, and from the data side, the processing can adapt by interpreting the data. So from that perspective, we have a federation of applications that just use the data independently of coordinating whether they produce it or not. And the data is then structured in a way we can understand it. But this is not actually changing the way we name the data. The name the data is just how we move it and collect it. But eventually, our data internally, we just have to be able to interpret it one way or another. So there is some coordination, and we do have many applications that can use the data, as long as you know the structure of the data. From this perspective, I would want to make sure that in this part, and we talk about naming in multiple ways, especially with the NRS, at the bottom, our naming is to do networking. And we should make sure that the naming allows us to do what we need to do.
Who are we now? LinkedIn or
No. Now I'm talking about the network here. So the network needs to move the data, get it from one place to another or multiple places, or in this case, we're discussing about caching it. potentially verifying in some type of signature. So I would prefer not to mix both uses and needs of us making sure we achieve and choose a naming system or structure that is appropriate for us to achieve what we want, because applications, they need many things, and they're going to want to optimize many things. That includes how they're going to name the data at whatever layer they're doing. It would be great if the system that we choose, the architecture itself, can do both, but this should not be necessarily our driver for what it's doing. Optimally is great, but it's not necessarily our goal. Let's make sure that we can do our job of moving the data around at the network.
Yeah,
right. I think what we're seeing is, I mean, there are certain requirements that we say anticipate or that we identify from a networking perspective, right? So referential transparency, immutability, and so on. So now we are looking at this from the application perspective, where people are often doing things slightly different, and so we are kind of reconciling how this fits together. And so I mean, you can build, say, ICN applications in, say, like constrained local domains. And I think the interesting question is, how can you come up with an architecture that kind of does not break the, say, global networking approach in ICN, that kind of fits to what we normally do in the network. And I think this is basically what's been discussed. Also has to do with other things, so like push, for example.
Yeah. So I think maybe we should stop here because in interest of time. So, but I think it would be really useful to try to document a bit about this things, because I think to be able to use this in a global context with all set of applications, all the services, if ICN should be an underlying data provider for all applications, I think this is a central thing, especially the time thing, to get that right.
There's been a bunch of more people come
Who's
into
next?
the room since we started, so I'm going to pass the blue sheets around again.
Yeah.
So that people can-
Ravi, are you in the room? Okay, so you are next. Actually, with a couple of presentations, and
So just pass it all around again so we get the new people.
Which one is the first one?
notifications.
I did that last time.
Yes.
I start with the one I did not
Which is
Which one do you want to start with?
do. We can do the design considerations first.
okay.
Design configuration. So you take that one.
Yeah, so there were like 3 presentations, and actually last meeting I was not able to do one of them, so I'll start with that, and then if there is time we can still run through those 2 presentations. Fundamentally, we have not made changes to these drafts, just that we couldn't do the IoT design considerations one. Sorry, I didn't see that. Yeah, I'll start with that. Okay. So next slide. Yeah, so these are the authors of this draft. Next slide. Oh, yeah, sorry. Point here. Or where is the? Doesn't matter. Okay. Okay. So yeah, so this is I just said this is more the status from the last IETF call. So there was a call for adoption. There were a lot of comments. I mean, we are I think in IETF 98, I guess. So there were like volunteers who wanted it for. We're still waiting for reviews from them. So, but we received a detailed review from Dave. So a lot of the changes that happened for the last meeting was primarily to address Dave's comments. So hope we can still get some comments from the volunteers and also anybody who wants to comment on this draft. So the draft itself has had some history. So it was 2 drafts that were merged into, so initially it was called a requirements draft, and then we changed it into a design considerations draft. And so this is the second iteration of that draft. So the main changes here were mostly, as I said, considering what comments we received from Dave. So we kind of, in the product section 6, we separated out the caching and the storage discussions. And primarily the changes have been all through the draft, but I think the blue ones highlight what are the new things we highlight. We identified some changes, some differences from what the T2TRG groups does and stuff. So I'll just run through the changes. So basic changes here is a lot of it is basically changed, reduce the term requirements throughout the draft to design considerations. Then we are not proposing a platform rather than architecture here. Sweep makes generalizations through the draft to say that ICN could solve all the IoT problems, those kind of statements. Okay, so yeah, we didn't make changes to the authors list, but probably we'll do that in the next round. So in the abstract, as I said, some of these changes are like, to basically propose to build an ICN IoT platform. We replaced it with something like a common set of protocols and services called ICNIT, which can be used to build IoT platforms. Then we removed some summaries that were described in the abstract. As I said, the changes mostly terminology in terms of, instead of unified platform, it's a unified architecture that we want to propose. So there was some discussion on having open APIs. So this was mostly motivated from all the IoT deployments that you see today is kind of pretty heterogeneous, uninteroperable, and also something to say that you need open APIs that would allow different IoT systems to interoperate with each other. So this is again one statement that was saying that for most of the IoT applications, probably ICN is a good fit. So, this is from motivate. This section primarily deals with, basically tries to highlight, why ICN is a good fit for IoT. So there's some discussions. There are many items here, and primarily we also provide some use case scenarios. So there are pretty much 4 scenarios that we discuss here: smart mobility, smart building, smart grid, and smart industrial automation. And fundamentally, they go into the specificities of the use cases, what are those specific challenges, and then why ICN architecture could be useful to address those challenges. So this next section is primarily deals with the IoT architectural requirements. So we lay out several requirements, starting from naming. That's fundamental you see in any IoT architecture. So there's some clarifications with it on the security aspects, security attributes related to naming, semantic, meaningful, or basically using semantic names, which is fundamentally nods with privacy. So we fundamentally modified those changes. Security, some more details have been added to clarify the scope of security here. Scalability aspects, again, this was one comment saying that it's fundamentally affected by object count, state, and rate of information updates generated by sensing devices. So all this has been taken into the update. So here in the contextual communication, we fundamentally introduced 2 kinds of contexts: long-term quasi-static and short-term context, which are more challenging to handle. So then there is more updates on IoT architectural requirements. This is same to section 3. So here the changes related to storage, caching. So here, as I said, we did not, in this part, we did not kind of separate the 2, but kind of combined it to give one kind of discussion on how, what are the fundamental requirements are from a storage caching perspective for IoT. Communication reliability, the thing on Open API was original here. We moved it to the one on introduction. Then we have the state of art, clarification IP-based IoT system as being service overlay. So this is fundamentally saying, okay, how the current systems operate and what are the drawbacks. So that's what we discuss in state of art. So we fundamentally start with the silo IoT architectures like BACnet and so on. Then fundamentally how the things are going in the IP world is to build some application layer unified IoT solution. So again, there are some things that we highlight there on basically differences between the object-based security model and the session-based security model. Some of the cost associated with the security. Then there's a need for, even in the IoT world, there's a need for multicast support, which is fundamentally done using application layer multicast mechanisms today. So there's this other thing about self-organization, which is very important for IoT, considering the large-scale devices that one fundamentally kind of encounters in the deployment. So, it's much easier to do with ICN because of its naming characteristics, which is not supported by IP today. So there's suitability of DTN. So earlier statement on DTN being endpoint centric. So we have clarified that DTN could potentially name content too, but again, the bundle protocol can be extended, but it will be very similar to approaching what ICN does, right? So advantage of ICN. This section fundamentally talks about advantages of ICN over IoT. This gives a kind of very nice discussion on the different aspects that favors ICN for IoT. So we talk about naming of device, data, and services. Again, security. Then again, most of this is talking about the changes that we made to address the comments. So design challenge. So on naming devices, data, services. In addition to clarified the need for carefully naming devices. Kind of Bore even covered a lot of those points. In addition to content, it generates persistent identity to ensure mobility. Names can be contextual. So ensure device is always reachable in spite of request aggregation. So there's some challenges that we added of using hierarchical names. And requires always a third party to validate name key binding. There's another suggestion of using the web of trust alternative, semantic based namings. So there's one item on that. So this is fundamentally using some keywords to request contents. Scoping has been rewritten from application networks point of view, confidentiality of names. So we have cited some new work on attribute-based encryption, access control, delegation schemes. Then the section continues to discuss security and privacy. We clarified comments that is related to the contextual nature of IoT. Again, the need for support session-based security based on the draft to create and maintain trust associations, modified discussions related to security implications for resource-constrained devices. Then changes. There have been some changes in the caching and storage. So as I said, main thing is that we split the two discussions. Again, storage has been discussed in the context of long-term and short-term storage, later being used to improve reliability over unreliable wireless links. This is primarily the usefulness that comes from the edge storage. So the other thing is on routing and forwarding. So this is challenges associated with routing in constrained domain has been added in addition to routing directly on names versus using a name resolution service. Then there's some changes on the mobility management aspects. So here's one thing is that mobility that needs to handle considering diversity and heterogeneity of different access mechanisms. So you need to handle, irrespective of how the IoT device is connected to the network, you still have to handle mobility. Self-organization. So this section has been rewritten to scale IoT devices. So we have added discussion on onboarding, device, service discovery, naming, etc. So the next section make it, so this is more about energy efficiency, I guess. So we kind of, so we removed the generalized discussion to make it more focused on optimization challenges in constrained IoT segments. As I said, there have been some new sections related to related to differences from T2TRG, security considerations, acknowledgements. So anyway, so these are fundamental, some basic things that we added to make the draft more complete. And also we added a lot of the recent work. So I know there's been more work that came out in ICNCCOM. Anyway, this is like a moving target, but we'll update the draft. If somebody wants to contribute into the draft based on some things, some of the aspects that have not been missing, or some of the recent results, please do write to us. Yeah. So as I said, like we have had this draft has been evolving for some time. So I would request to use it to take it up as the RG draft so that we could work on this further.
Okay, thanks, Ravi. I mean, so this should be decided by the group, right? So it's not, and the chairs are deciding that. So criteria that would be, say, relevant for making the decision is, so whether, you know, the group thinks this has some utility and should be published. Another question could be whether you want to, you know, spend more time on this in the future. So what we could do now is kind of get some feeling in the room. So first of all, who has read this version 1 of this draft? Okay, so I see like maybe 5 to 7 people. So who thinks this could be adopted as a group item? Should be. Who wants to see this adopted? So.
Yeah. Sure.
Okay. So
No
like seven-ish. Okay. All right. So we note this down, but we're going to reconfirm this on the main list, and so fundamentally we have to make a call on this.
Sure.
All right. So which one do we want to take next?
Again, and those would be repeats, but if you want to do it, we'll do it.
So to do the notifications?
Yeah, I mean, sure, yeah. So, yeah, those same thing. It's the same material.
Okay.
So.
Yeah, we don't have to spend time on
Okay. So is there anything else on IoT somebody wants to? All right. Okay, so I think then you can still stay because
I'll go with the 5G one. So.
Right, exactly. The 5G.
Is there some water here? Or thanks. Okay, so this draft is primarily looking at. So there's been this effort on writing a deployment draft backbur and all, and one of the options there is from how ICN can be deployed. We said, okay, we can look at some greenfield IoT deployments. The other promising area that I feel, or the authors feel here, or even from a deployment draft perspective, is to look into 5G as a potential area where ICN can basically address problems that might be difficult to be difficult to achieve with the current mode of doing things. So the main goal of this draft is to give folks a background of introduce them to the 5G next generation core network architecture, and basically then we provide some extensions to share exactly how ICN can just not be implemented as some kind of an overlay service, but as an integral service, so that you can bring ICN really close to the edge and basically use a lot of its efficiency for multicasting or handling mobility and so on and so forth. So as I said, the main, we'll be talking about why we need, how ICN could be kind of enabled in 5G, the architectural differences from 4G, the 5G core proposal. So enabling and then basically seeing extensions of how that would be required to this proposal to enable 5G, sorry, ICN. Again, this is not something that it has gone through 3GPP or something, but there are more folks here who are kind of more into the core 3GPP discussions, and you see that, okay, something that we are saying here is not right, so please provide us the feedback. And we basically end the draft with providing two very compelling use cases. So one is for edge computing and for seamless mobility. So the main motivating points, as I said, is first from that deployment perspective. Second thing is that 5G is very ambitious in basically opening the networks to support very heterogeneous type of services and applications, right? So then for that, you're just not looking at current broadband, but looking at to support all kind of IoT services with very high reliability, what's basically quite famously with this 1 to 10 millisecond latency requirements, where you require tight control loops and stuff. So to basically handle this, the 5G basically said, okay, we have to consider something like network slicing, because you cannot basically have one network and have these kind of heterogeneous requirements supported on top of it. So network slicing fundamentally talks about slicing the network from the UE, RAN, transport core, considering all this for different services. So, and there is network slicing itself. You can talk in terms of granularity, in terms of a slice per service instance, or slice can be composed of many sub-slice and so on and so forth. The main thing is that they're dynamic. They can be elastic, limited lifespan. As I said, it's end-to-end. And primarily, they leverage principles of NFV and SDN to enable programmability and service management. So again, as I said, the main thing about network slicing is to introduce kind of new architectures to address these problems in a new way. So the more famous one would be saying that, get rid of this GTP tunnels because it's very costly. Particularly if you consider to that you have to handle for all these IoT devices, you need to always manage the state in the control and the user plane. ICN, so in that sense, we basically had one paper that said, okay, ICN, how ICN can coexist with other IP slices and stuff. And then, as I said, there are many features that ICN offers. So it's more useful if you offer it as an integral service, because it addresses many problems related to naming, security, mobility, multi-homing, caching, and in-network computing. So, as I said, why is this relevant? If you look at the 3GPP roadmap, as we speak right now, I don't know the current status, but the release 15, which contains the 5G new radio spec. Yeah.
This is Akbar. Just a question. In previous discussions, the way I understood it is that there would be no required changes on 3GPP specs to support this, meaning that ICN would be an application, let's say, that could ride transparently on a 3GPP network slice. Mm-hmm. So there would be no, the way I interpreted that is that there's no required 3GPP changes. Is that still your?
No, I said, like, we want to ensure that, if operators are offering, are officially supporting an ICN stack in the UE devices, then they should be able to handle all the configuration and basically the state management in the network and in the user device in a more formal manner. In the sense that what it allows you to do is to fundamentally bring in this kind of ICN semantics into the radio, into the MAC, fee integration, and even basically in the core network architectures. And also, the thing is, if you're trying to put this, as I said, if you want to really handle ICN mobility, you have to bring it, and you want to actually have some notions of flat networking, you want to bring ICN very close to the edges, right? Then you fundamentally can, otherwise, I have one slide on session mobility. If you're really pushing ICN back, then you have to handle the state for their 5G core as well as ICN separately. If you bring it closer, then you can leverage things like Cloud RAN to fundamentally, you can localize a lot of the state and do things more efficiently. So this one is fundamentally saying that you want to have it embedded more kind of as an integral offering as part of the 5G service, not an overlay.
Okay, so this has evolved since the original. Okay, that's fine. I just was trying to understand. Okay,
At least that's the point. As I said, it's whether 3GPP buys this, I don't know, but at least this is what we are trying to push in this draft.
Okay, thank you.
Yeah. So as I said, this is a 3GPP roadmap. You have the release 15 that's happening now. So it has a new radio spec and it will have the initial kind of specifications for the 5GC. That's a next generation core network architecture. But since 3GPP evolves more incrementally, the initial kind of applications would be towards supporting the enhanced mobile broadband kind of things. But there is a technical specification which is 22261, which covers a lot more requirements. And that would be mostly considered as part of the release 16. So what I feel is, because if ICN could be one of those architectures that could enable you to solve some of this problem, and probably you could see it as part of this release 16 kind of release in that support specifications.
I have a question framing this, and I haven't been coming. I'm the IETF chair, Allison Mankin. This group isn't producing standards. The 5G and 3GPP, do the 3GPP people actually draw on non-standards work? And is this timeline sensible? And is this a good use of folks' time to be talking about this?
Yeah, I mean, the only reason I bring the reason we put this draft is to more encourage people to see ICN from the 5G's perspective. So, I mean, as I said, you want to see ICN ending up somewhere, right?
So, I mean, it may lead us to a different approach to the technology. Maybe the chairs can also help us to discuss this. And I apologize because I imagine you've discussed it, but it's probably an evergreen topic. Like, what is the role of this group, which is a research group, in relation to standards bodies who are trying to do development?
Right. Actually, we wanted to comment on this as well. There are different ways how you can, do research or, work on ICN for mobile networks, right? So, I mean, ICN has potential to, do things radically different. So mobility management, for example, security and so on. And so there are hard research questions, how you could do that. And this would probably not be directly related to current work in BBP. It's just far more out and much more, radical perhaps. And so this seems to be, more oriented to what's currently going on in BBP regarding 5G. And so the question really is, so what is the intended audience for this?
So this audience, this is still for the ICN community. As I said, just like we are exploring ICN in the IoT space, right? I mean, you could also look for ICN in the context of 5G. And primarily, I say that because 5G has very challenging requirements for different services. And if we can show that, okay, ICN can solve this problem uniquely, that something else, and based on that the current technologies cannot, then probably it would be accepted as one of the technologies in the 5G space. It's still from the research perspective, sir.
Also, there's a sort of short-term versus long-term thing going on, which is the 5G standards, they're going forward, they're moving. One of the things I think this community was concerned about was, are there going to be enough hooks in a 5G system so that we can experiment from a research point of view with ICN systems in that context? Or is it going to be what we've had in the past, which is a really inconvenient way to build overlays, and you sort of live with the difficulties of both systems? So one of the things that's in this draft, and I think is a theme that a bunch of people in the RG have talked about, is making sure that in certain timelines of 5G, there are hooks there to be able to insert ICN style technology, either research-wise or experimentally, so that we're not sort of left on the outside. So the slicing stuff that Ravi talked about may wind up being a critical component within the 5G standards that is a sort of like an enabling substrate for us to do our research work.
But so you can understand why I can't hear that from this talk or this or the current version of the draft. So I think it would be clarifying if that stayed at the people's forefront. And then, I know experiments will happen. I know that's actually very, very real, but I'm not hearing it in the room today. So I'm asking for, continually reminding us that what we're doing here is looking for the experimentation, not looking for a short-term take an ID from here and standardize it, because that would be a different discussion.
No. It's not for standardization, but I mean, I'm saying if we can show something significant here, it could influence how 5G shapes up, and because it's a continuously evolving process. I said release 16 is further out. There are discussions, so we could inject some of the
I'm just going to take
findings
this a
from
little
the
bit
others.
further, but there's a whole process for working the standards tracks into the 3GPP with a lot of people who liaise. I'm a veteran of that from my transport area days when that area was under my area. So I really want to disambiguate it. And it's probably really disambiguated for almost everybody in this room, but I checked with Melinda and it wasn't for her. So I appreciate your keeping us clear on it. Thank you.
Hannu Flink from Nokia. I fully agree about what you are saying, because 5G, as you saw the roadmap of 5G, how it processes, it's going quite peacefully. So how we are going to map ICN work to it? It will be a constant challenge. I have a question related to this network slicing. So in your view, or Dave's view, do you see that there is some sort of underlying technology that provides this slice for ICN, or is it the other way around, that ICN is the technology that provides means for creating slices? Because these two things are different. If we just map ICN on a slice container, we are losing quite a lot of functionality. For instance, 3GPP has already slicing model, and it says that what are the common features between the slice and what are the slice-specific things. And part of these slice common features, registration, mobility, things like that, why do you need to implement them again on ICN slice?
No. So yeah, I think it's the first part. It's not basically, even in this draft, we are not saying that you have to introduce something in the control plane, ICN. It's not about, it's more about enabling an ICN data plane, so you get the maximum benefit out of it. So it is not about, the control plane remains as is, but you just extend the control plane to enable ICN UEs that have ICN stacks or ICN applications to be admitted legally into the network. So it is for taking that view.
Okay. Thank you.
Yeah.
Satoru Matsushima from SoftBank. If you really want to make that concept in 3GPP happen, so you have to go to 3GPP.
Yeah.
They currently focus on the slicing in just only on control plane. No concept in the data plane for the slice. So if you want to make concept for the data plane for slicing, you need to go to 3GPP.
Yes, I do agree with
It's really
that.
hectic to figure out the control plane spec for release 15. So then they need much more delegate to work on the user plane study. So if you do that, if you want to do that, you bring your colleague to the 3GPP.
Yeah, I agree with that. As I said, like we are discussing here, I'm not going to influence 3GPP in any way, but as I said, this is more for the ICN community to understand the 5G framework and study problems in that context. There is well-documented requirements and all this stuff. So whether can we solve some of those problems? So that's the main motivation. So as I said, there are some fundamental architectural differences from 4G LTE. I mean, there's some of these things like cups and all are already there. Probably LTE does it. But in case of 5G architecture, it's more kind of modularized. So that probably we'll discuss in the next slide. I have something about that. And there's something on decoupling the RAT from the user plane, because you are fundamentally extending the entire spectrum boundary to 100 gigahertz, and then you can introduce new kinds of RATs with potentially different MACPHY kind of implementations, and then hook to basically different kind of core network slices. And there is this IP PDU support, kind of non-IP PDU support. So there is something for the unstructured PDUs, and these are like mostly, I would understand, like some kind of opaque PDUs that you can carry through the 5G core. And probably that could be one of the could be an entry point for ICN, where you could formalize something like to carry ICN PDUs in the 5G user plane. As I said, this if you also consider that this could also be useful for other LP-WAN kind of implementations. And so, as I said, ICN can potentially leverage this and formalize it. And if you look at it, 5G is mostly coming from the service perspective. You have hooks to basically influence all your sessions and all with using application functions. And so things are basically more kind of implemented in mostly using some of this cloud development-based principles, and where you fundamentally talking about network functions, not kind of monolithic gateways and stuff. So it's more kind of very flexible architecture here. So this is, I mean, one of the kind of the variants of the 5G architecture here. So you have, you have the kind of the end user device. The end user device now can be not just a smart device; it can be IoT or vehicles, whatnot. Then you have the RAN component. And what you have in the user plane is basically what we have. Probably I can use this. Yeah. What you have here is basically some new kind of functions that they've introduced in terms of uplink, classify, and branching points. And these are fundamentally trying to make the network more service aware. So you can take some service aware decisions to steer traffic to particular data networks. And I think this kind of features will also be used for to do things like kind of mobile edge computing. Then at the control plane level, you have, basically fundamentally they basically talk about common control plane functions. So this is saying that so these are basic control functions that is kind of more non-slice specific. So for irrespective of what UI is joining here, you could probably can be served by the same AMF, or then there is something called as an SSF, which is the network slice service function that fundamentally says, okay, which slice this particular UI can basically be belonged to and stuff. And then there is this kind of very slice specific session management functions, right? So in the sense that you could have parallel kind of different logical networks being controlled by different session management functions, right? And they could have completely different control plane functions. A good example would be like if you have very static IoT devices that doesn't require mobility, then you could fundamentally, you may not require any kind of anchor points. It could be just be a kind of flat network that feeds into that particular service points, right? So this is basically talking about some of the control plane functions. So as I talked about, there are many things that it's very rich kind of control plane function components.
Ravi, sorry for interrupting. So we had scheduled 15 minutes for this presentation. Okay. So you need to figure out how to make good use of that.
How many minutes do you have?
Not many more. So.
Not many more. Okay, no problem. Sure. So so the main thing here is to basically say that you have functions that handle things like authentication, identity, mobility, and connection management. And of course, things like policy charging, lawful intercept is all important in this architecture. Then you have this, as called session management functions that fundamentally do the traffic steering in the network. And then there is this kind of user plane functions that can be playing different roles for as anchor points or branching points and so on and so forth. Then there is all this kind of functions to keep your subscription state and authentication information and so on and so forth. So as I said, the user plane function, and you have the new radio, and then you have different UPFs that can play any of these roles. So as I said, from an architectural flexibility perspective, you can actually, so today's architecture will be like one flat network, but 5G will allow this kind of an architecture. So you can have things like one network for supporting something like LTE, EPC, you can have something for ICN, and then you have something for LP-WAN. And each of these networks can have their own kind of control functions kind of customized for that particular slice. So irrespective of where the devices are actually, so they can be kind of hooked to that particular slice. So, and there is things like you can switch between one EMF and another EMF and so forth, so that you can get the particular UE hooked to that particular slice. So this is enabling ICN 5G network. So as I said, like the main goal of this architecture was to say that you don't want ICN as simple overlay, but you want to have this kind of UEs with ICN stacks officially kind of formally supported there. So most of the extensions that we are proposing here is to basically allow the configuration from the ICN, say, services to actually go into the ICN UE. So this would include something like naming, something security-based functions, or things like event forwarding, establishing the forwarding state in the UEs to basically allow the traffic to join the correct ICN data network. So as I said, okay. So this is, again, as I talked about ICN UE, you can...
So, Ravi, one suggestion. I mean, maybe you could get to your conclusion.
Sure. Yeah. So yeah, I'll go rush through this thing. So main thing is that we approach some extensions to basically support ICN flows formally in a 5G network. And of course, we have Prakash draft also that talks about how ICN could fundamentally sit with IP stacks. These are fundamental ICN extensions. The main thing here is that we have an ICN anchor point, right? So this ICN anchor point is where it can be ICN gateway or ICN service gateway. And this point could also be the point where you're handling ICN mobility and stuff. And then you have ICN data network, which is simply an ICN network. So in the draft, we have like two use case scenarios that we discussed. So we have, basically we talk about in a connected car scenarios. So, and basically say, okay, if you're doing this on top of an IP MEC.
Okay, sorry, there's no time for the use cases.
Okay, so anyway, you can read that. The draft, I've given some more elaborate. You can just go through that to basically say how that differences exist. And then we talk about the ICN session mobility here.
Conclusions.
Yeah. So, okay, I'll drive to the conclusions. Okay. You can read through that in the draft, no problem. So the main, as I said, the main idea of this draft is to provide an opportunity for people who are looking into 5G to contribute to this work. So the main thing is, as some of the comments suggested, it's not about we are proposing something standardized and normative references to them, but to say that can fundamentally ICN solve problems within the 5G context. And as I said, so there is some provisions there for unstructured PDU. And as I said, the network slicing itself offers you an opportunity to create ICN networks, and 5G can support that. And so, as I said, there's a good chance with this kind of draft, and if there is good supporting research material on that, we could influence research release 16 to look at ICN more seriously. So that's what the main idea of this draft is. Thanks.
Okay, thank you, Ravi. So just quick comment from us. So, I mean, so as we discussed earlier, so this is potentially so important to make sure that there are like sufficient hooks for ICN in the future in mobile networks. On the other hand, this is also a very specific topic, and we need to figure out so how to deal with this productively. And I mean, we are happy to discuss this with you or anybody who's interested. So there are different options. So one is, for example, that we form something like a design team or special interest group. You could also have breakout meetings at the IETF or wherever. It's just difficult, I mean, to go through all these details in a presentation like
that's
this.
right.
I mean, not saying it's not interesting, it's not important, but we have to find a productive way to deal with that. And,
Sure.
So let's discuss it. I'm happy to find a solution for that.
Sure. Okay. Yeah. Thanks a lot. The comments were also pretty good. Thanks a lot.
Right. Okay. So can you just next is Prakash with ICN for LTE. Maybe you can say one word in the beginning. What's the relation of your work to Ravi's? What's the difference, perhaps, so that people who are not that familiar in mobile networks actually understand?
Okay. Yeah. Good morning. I'm Prakash from Cisco. So question from chair, what is the relations of my work with what Ravi is doing? Incidentally, I'm co-author with Ravi as well. And I have always been very passionate about non-IP PDU in the mobile, because they always talks about whether you have IP based data or you have non-IP based data. So ICN probably provides an opportunity to use this in the mobile network. So my work is more related to what in the current network, in the 3G network or in the LTE network, how you can deploy ICN. And then since we are working through the 5G architecture, we can take large part of the work which is we are doing here into the 5G core. I have a lab in Cisco where we are trying to do simulation of what we are presenting here. And if you guys want to see a demo, and we are happy to share with you guys, no problem. So this is the relations, and I'm going to talk not entire draft, but only the changes what has taken place for last couple of months since the last IETF. So I'm presenting on behalf of some of my other co-authors. Dirk Trossen from InterDigital provided excellent input along with Akbar and Ravi from the last IETF. Those three took the ownership to give us the feedback, and all of their inputs are incorporated into this. If you can go to next slide. Okay. Okay. Okay, so why did we start working on this? The first thing I realized about 1 year back that most of the work on the ICN is done only as an overlay. That means not disturbing anything at the IP layer and just use the ICN as a protocol to transfer the data between the consumer and publisher. It has good benefits, but it does not really leverage the entire transport infrastructure and changes into that. So our work has been that how can you implement natively into the mobile devices or the devices which are going to consume large chunk of the video content. So that is the goal. And the second goal is that since the signaling part or control part is so complex, is there any play for ICN to make any changes there, or it is just the data plane? So there is quite a bit of work we had done in identifying the key point. And someone asked question to Ravi earlier about, hey, is ICN is used to create the network slice, or is ICN is used inside the network slice? So ICN is not a technology to be used to create the slice, because ICN is mainly used to deliver the content. So there has to be some other existing technology, either based on the NFV Mano architecture or something else to create the slice, but create the slice where the information can be transacted using the ICN. Okay. So this is the version 4 we are presenting. We released on November 11th earlier. If you look at this architecture, you have a phone on the left side, and then you got all the transport elements, and most of the information is going encapsulated from the radio network all the way up to the packet core and then going out. I highlighted some area where there is an impact or the changes required in terms of the ICN supportability. There are 4 different options in which we can deploy the ICN. The first one is IP over IP. What I mean to say is that there are 2 levels in which the IP is used when we try to get the data. One is at the application layer, so where the handset gets the IP address and you get the information transacted through that. And another is the beneath layer IP used in a transport. So when we discuss about this draft, the context is how can you implement ICN, or what are the different choices you have to implement ICN at these 2 different layers. So first one, no changes. The second one is ICN over ICN. That means the handset is being a ICN capable, and also you are trying to implement the changes beneath the transport using the ICN. The third one is that you use ICN as an overlay. So that means the handsets are ICN capable, and then the underlying transport infrastructure is IP. And the last one is what InterDigital and Akbar's team has been working on H2020 project, where if you use an IP, but the beneath transport infrastructure is migrated to the ICN. So I want to quickly go over what are the different ways of where we can implement. So if you see in this diagram, this is a very high level view And in the draft, I provided a lot of details about what changes are to be done in terms of this protocol stack. So on the top, you see there are two different kind of applications on the device. And we are not just talking about the smartphone. We are talking about any of the clients trying to consume information using a cellular network. So you can have a ICN applications or you can have a traditional IP-based applications. So what we are proposing is a middleware or the layer, what we can call it as a transport convergence layer. And this transport convergence layer provide the functionalities like a ICN forwarder. It provides the capability as type of radio selection, whether you want to use the Wi-Fi or you want to use the cellular or you want to use any of this choice. Also, it provides an option in terms of determining the lower level parameter, like if there is a congestion, how much congestion is there, or if certain content is available more preferably on the IP versus ICN, or you can use it at any additional cost parameters and like that. Also, we have provided option for the API at that layer. So imagine if you want to create the network slicing based upon the client itself, not just based on the radio, but on the client itself, then using this API, you can provision. And Akbar and his team has done quite a bit of work in this area. So I found it very interesting and we incorporated that. Also, the lower layer part is we are not making any changes into the protocol stack. I'll cover in the next slide a little bit more in detail. This diagram shows very high level view about where the changes takes place. So you see on the extreme left side is the UE or the client, where you have the application sitting on the top, then you have transport convergence layer and the network layer. And the other elements, what you see is the radio interface, the base stations, gateway, and on the extreme right is in terms of the content provider. And you see here in the protocol stack, there are two different options. The first one being on the top here is the IP, which is assigned by the gateway, and this is the same IP is used by the content provider, and then below this is the transport part. Then this slide is further extension about how do we implement the dual stack. This slide describes in detail about how you can implement ICN at the edge of the radio or at the gateway. So there are three different options. Even if the client requests ICN based information or IP based information, it is not necessarily that transport is supporting that. So we want to provide an option in the radio or E node B where you can send this information either on the pure ICN transport, you can send this on the existing IP transport, or you can send in any of this either IP or ICN options. In this slide, we are describing about the transport options, and in the transport options, you can have this ICN based forwarder or the ICN based routers implemented there. I'm sure you are aware of Cisco's work in the hybrid ICN. So where we are giving an option that in the routers, you have an option to turn on the feature in terms of the ICN forwarding capabilities or IP forwarding capabilities or both of them, and then you can just select any of them. Think about the days when we implemented IPv6 into the router. So the choice was that based on your protocol configurations, you can configure IP or V4 or V6, or you can configure as a dual stack on that. So something similar to that what we are proposing. I want to quickly walk through about the gateway and what changes are required in that. Again, this whole approach for this draft has been least disruptive to the work what 3GPP is doing, but leveraging the 3GPP architecture to implement the ICN capability into that. Okay, so what we want to use here is that there is a field called protocol configurations option, which is called PCOIE, and that happened to be a protocol stack where we can define the ICN related parameters. So when the client attach, we can send that this client want to attach as a IP, or this client want to attach at the native ICN, or this client want to have a two type of attach at the ICN or IP both, and then let the application determine how it want to use. So we want to use this PCOIE fill with this right option. It's about 8 octet fill, and we can just leverage this capability to do that. Also, since the gateway is the anchoring point, because it provides the capability to host the session when the handset or the client stays there from power on until the time it just moves out. So it is able to maintain the session. We can also have the capability of ICN forwarding into the gateway. So you can serve the content locally from there, or you can serve the content from the radio or from the eNode B as well. We also did quite a bit of work in the security area, because it's very important. Unless the security aspects are handled carefully, it is not going to be a deployment option. So we identified about 7 different areas in which this impact is there for the security. The draft provide quite a bit of details around that. The 3 areas where we really need to do further work on this is in terms of the deep packet inspection. So basically, when we are doing the inspection of the packet, either for the lawful intercept or for some additional billing configuration, something like that, that part has to be analyzed a little bit more from the ICN point of view. Also, in terms of the LI capability itself, because the IP-based lawful interception is very well defined and is implemented. When we want to do a ICN-based lawful interception, there is an impact on that, and we had to do quite a bit of work in this area. So what I believe is that this draft is fairly stable now for some time. One of my requests will be that if we can adopt this as a working draft. And also, I would like to encourage more interaction or any of the thought process or any questions you have on this.
Thank you, Prakash. Are there any questions on this, first of all? So one question from us. So have you actually received any feedback from, say, non-ICNRG folks on this? Have you been able to present this to somebody outside this community?
Yeah, thank you. Actually, I presented this in one of the industry, 2 places actually, 2 industry summit. One was in, of course, Cisco Live. So a lot of Cisco customers were there, and they were all asking me for showing them the demonstration which we did. Then I had presented to the Linux foundations recently, because they are very much interested in the virtualization of the packet core and what is the impact. And I incidentally had about, I think, 6 service providers in the audience, and they are all very interested to see how you can implement on this and then show to them. So we are following up with one at a time to give them the demonstration of that. So these are the 2 incidents. And then I recently approached IEEE they have called RAFNet. For the Forward Internet conference in Toronto recently, I presented, and a lot of feedback on this. They were all very interested. First of all, they are not believing that it's possible to implement it. But when I explained to them and I gave them the demo, they were giving very positive feedback. So I'm seeing a lot of interest, at least from the group I had interacted with. And within Cisco, I had presented to my company many forums, and they all like it, this work.
That's good to know.
Yeah.
All right. Okay, so who has read version 4 of this draft? Yes, yeah. Not too many people. Okay. But let's still ask. So, so who's in favor of adopting this as a group item?
Dirk, if you don't mind, I just want to make a comment. I'd given review comments, and I checked. They were all answered, so I had forgotten to answer that on the email, but thank you for addressing all my comments.
Okay, yeah, thanks for pointing that out. So let's anyway ask, so who's in favor of adopting this as a group item? Who wants to, see more work on this being discussed here? Who thinks it's useful? Okay, like four to five people, right? So that's not too many. We can still anyway confirm this on the mailing list. So yeah, so this is say informational material, right? That kind of explains so how you could use ICN like in a maybe not too invasive way, and also probably points out some of the say open questions that still need to be addressed, like intercept and so on. So yeah, there's some utility. We need to figure out how we deal with material like this. So definitely we should talk about it. It's important to understand. So yeah, we're going to ask the question again on the mail list, and we're going to have some dialogue with you how to move on with that.
Okay, yeah, thank you. And thank you, Chair, for providing excellent feedback. I mean, I got a lot of input from Dave on and off, so it's very nice. Yeah, thank you all.
Thanks, Prakash. Next up is Akbar with deployment guidelines. Where's the clicker? Yeah.
Okay, thank you. Okay, thank you. So I'm going to be talking about the deployment considerations for ICN on behalf of my co-authors. So just to set the stage, the ICNRG charter has an important paragraph where they talk about need to define, this is text lifted directly from the charter. Basically, they said need to define concrete migration paths for ICN deployments, which avoid forklift upgrades, etc. So that was our motivation, that we saw basically there had been one very early draft Rev 0 from a few years ago that started work on this topic but never progressed. So we thought it's an important area to work on, especially my company participates a lot in EU Horizon 2020 projects. So we have an interest just in general in the ICN technology. So just a summary of the key takeaways from the draft. Basically, what we do is we categorize the different ICN flavors that are out there and into 4 meta classes in terms of how they could be deployed. There's the original clean slate, new internet approach basically. And then there's the ICN as an overlay, ICN as an underlay, and ICN as a slice. The slice referring to the 5G slice that was referred to earlier on. And basically, we start off the draft by categorizing these 4 classes, and then we try to analyze the different aspects based on that. So the next thing we did is we looked at all the different trials that are publicly available, and then map them into the different categories or the classes, the 4 classes. So basically, I just gave an example here: FP7, SAIL, NDN, testbed, hybrid ICN. These fall into the ICN as an overlay meta class. And then the next line there, the Horizon 2020 projects, these are the ones I'm familiar with because we participate in them. Point, right, flame. Some other ones like NDN, IoT. This I got from Thomas. He gave a very good some very good references there. They fall into ICN as an underlay. So again, we sort of looked at the basic deployment configurations that are available, looked at some of the key trial experiences and categorized them. Then we looked at some of the, let's say, key challenges that anyone deploying ICN would probably encounter. Typically, of course, you would start off with the applications because that's the end user that they would see that. Then we looked at more sort of network-specific things like CDN migration, edge network migration, core network. And based on our previous analysis of the different classes that are out there, we gave, we did some sort of discussion and analysis of, how could you
ease application migration path, and we looked at the different categories and gave some sort of analysis there. And then towards the end of the document, we tried to keep it at a high level. We didn't go into, these are the specific exact bits and bytes you want to change, or these are the working groups you want to address things in. But basically, we identified some deployment issues that we believe require further standardization, basically to aid in interoperability. So that was really the lens that we looked through, the interoperability lens, that if we were going to see wide-scale ICN deployments, what type of things might you have to standardize? And some examples here, the ICN mapping to HTTP, because a lot of the traffic in the existing internet is, of course, HTTP. The dynamic naming, this, there was a good discussion on this at the beginning of the session. Routing interactions, we got a lot of feedback from Cisco on that, about routing interactions. So basically, some discussion there, and essentially a summary table at the end of that section highlighting that these are the top level things probably that should be looked at in terms of further standardization. And oops, okay, sorry. And then, okay, while we go, okay, I'll just switch back to the right page. Okay. And unless you want me to go faster, am I going? Okay, okay, okay. And then at the end, we had a summary. This was a comment that came 1 or 2 revisions ago, that there was a lot of information, and to basically have a set of conclusions there. So basically, what we did is we looked at everything, made a synthesis of the key points, and imagined that there was an operator or some other entity looking to deploy ICN. And, of course, they could read through the whole document, but there would be a nice summary section at the end saying, okay, look, these are the key takeaways. Some of the takeaways were actually, obvious at the end, but interesting. For example, all of the field trials, they were all much less than 1,000 users. So one of the takeaways, for example, was that if anyone deploys ICN, they should gradually increase the population of devices, because really there's been no field experience beyond 1,000 devices, and similar points. So that was really a synthesis of existing information. We didn't really try to do anything outside the box there. We tried to really stick to what was there in the sort of in the history. Okay, that's a summary. Any questions about the summary? Okay. Then now let me go into the actual changes. This is the current table of contents, of course, probably a little hard to read there, but basically it maps to basically the key points that I talked to before. We covered deployment configurations in section 3, deployment migration paths in section 4, deployment trial experiences in section 5. Section 6 covered issues requiring further standardization, and section 7 was the conclusion. This is the overall revision history and sort of history of the document in general. Our first rev was in Chicago that we discussed. We got good feedback within the meeting. We addressed that. Then we got a very detailed review from Dave Oren. So that, as usual, the review was very good, and we addressed those. Then we had more feedback during Prague, and then after Prague, actually we did an update after Prague immediately, and then we had very good feedback from Prakash and 2 of his colleagues from Cisco, so we addressed those. In terms of the key changes, well, I'll just go through this fairly quickly unless somebody has a very specific point. They're basically listed there, I think, comments on various sections, so we just wanted to list it for the record, just to make sure that it was also for ourselves to make sure we captured everything. That was between revision 3 and revision 2. So revision 3 was a revision that we did right after Prague. Again, some other ones. Yeah, I wanted to mention, I don't see Thomas, but we got some very good information from Thomas about ICN experiments over low power WLANs, and they were basically, oh, there's Thomas. They were basically an underlay configuration. So that was good, because most of the other well-known experiments are overlay. So that was one more underlay. So I was happy with that. Okay. And then, this was the big update due to the many comments we got from Cisco. So the one very good comment that we got was really, we had started off the document just by talking about a core network, access network, and CDN. And the Cisco comments pointed out that there's many other things in the internet beside those. There's edge processing, data centers, etc. So, we had a choice. We didn't want to go through the whole document and try to potentially cover every single type of network there, because the list would probably never satisfy everyone. So we at the beginning we tried to in the definitions really give some text there saying that, look, there's many types of networks that ICN can run on, but for simplicity in the rest of the document, we're just going to talk about access core and CDNs for simplicity. But we did try to make sure that the reader knew that there were, you could run it in a data center, obviously, and it would probably be very attractive in a data center. Then there was some other ones which were, I think they're just self-evident there. There was this reference to the MANO support for ICN as a slice. So that was, I think, referring back to the previous discussions about 5G. So it looks like actually this onap.org actually had already been sort of looking at that. So the industry has been looking at running ICN in some fashion, I guess, in a slice. We put some more details about the Cisco's hybrid ICN. I guess it's not just Cisco, but they're running the project there. So there was this open source CICN. So we added that into the list of trials. And I think that's it. So basically, next steps. Obviously, we're still open to any input, but specifically any ICN trial deployment experience that anyone wants us to add. I think that would be useful. And then I think this is a pending thing that I'll just turn over the chairs to the last comment.
So we've had a few people give a lot of attention to this document, but it hasn't been a lot of people. So I think it's important that a broader group of the folks in the the participating ICNRG take a look at this. Let me just ask, of the people who've had any chance to look at this, who thinks this is the kind of material that we ought to adopt as RG and get published for wide dissemination? Yeah. Okay. So one thing we could do is get it adopted rapidly and then progress it with more review as a formal thing. So I don't know how the other chairs feel. I feel relatively positive about doing it that way. So why don't we make a call on the RG list to see what kind of support we have and what new eyes we can put on this document, because there've been the same set of maybe 5 or 6, 7 people that have looked at it in detail. Does that make sense to people? Yeah. Okay. So that'll be an item here. Allison.
I just had a question about a specific about the decision to kind of marginalize the idea of ICN as a protocol in completely pure ICN edge networks. Is that a permanent thing, or is that something that you can discuss further? Because it looks like you had more edge emphasis and then took it away again.
Okay, I may have given you the wrong impression. I don't think we didn't take away emphasis on edge. I think it's still there.
It's small though. I just took a look. I just read through it's relatively small in the draft at this point.
Okay, so I guess you looked at the beginning sections where we categorized the different meta classes, and we had some text there. We could expand on that. We didn't reduce it, so maybe we can expand on that if you think there's not enough.
So this is no IRTF had. I was just thinking about the things that NDN has done where they take over a whole building and it's really pure ICN, and there's a lot of functionality there So it's not just a data center, it's
so-
kind of an enterprise.
So from a deployment standpoint, it's actually an overlay.
What
Close-
if you're connecting to other?
No. The actual deployment of NDN in that building is an overlay over UDP. So
Okay,
from a
so
deployment
yeah,
standpoint,
yeah.
it's actually deployed as an
I'm not
overlay
actually- I
and
don't
not as a
parse
clean slate.
that, whether NDN, which protocol stack, so much as the question of if you have an enterprise that is running NDN ICN in a pure form, is in a form that is purely ICN, no IP at all, is that a deployment or not? If it actually provides valued functionality and does a huge amount for that enterprise, will that actually be a deployment in the context of a document like this one?
I can give one example. I don't know if Dave wanted to add something, but the example we got from Thomas, which was basically running ICN directly over Wi-Fi. So it was basically an underlay, and it was in a campus. If I recall correctly, it was a university campus trial. So that was an example of running ICN directly, as the fabric, and then running IP on top of that. So we captured those types of details, for example, in the different examples of trials. And as Dave mentioned, I mean, in the meta classes at the beginning, we mentioned that the overlay could include an edge, it could include a core, it could include a data center, similarly for the underlay. So I don't know if there, obviously we could do further clarification, but that was our approach.
Okay, thank you.
Thank you, Akbar. So we're moving on with network coding. Matsuzono-san, are you in the room? Yeah. So while we're setting up, just one comment. So I don't want to put you on the spot, Akbar, but so what I noticed, so let's not refer to each other as Cisco and Huawei and so on, because we are not a standards group, and we're some are just individuals, and so let's be a bit, pay a bit attention to that.
Okay, apologies for that. Sorry.
Thank you.
Hello, I'm Kazuhisa Matsuno of NICT. So we initiated making a draft of a network coding research group. The title is Network Coding for CCN and NDN. So it's highly related to in this research working group. So I'd like to briefly introduce the context and the content of this draft. So, NC, it's short for network coding. NC for CCN and NDN has been an attractive research topic. So actually, so far, there are interesting and significant papers presented at Good Bennett and Journal, such as Infocom and it will be Trans Multimedia and so on. And it's very interesting topic. And we had two presentations at the last IRTF meeting of network coding research group. So one is Cedric-san introduced the concept and the context of NC for CCN and NDN, and including the content of paper at Infocom. And Hitoshi-san is presented our Infocom paper as a use case of network coding for CCN and NDN. So we in this meeting we thought that we need to clarify and specify the requirements and potential challenges or research items for network for CCN and NDN. So there are agreement on that. So we initiated making this draft. So the purpose of the draft is to so actually ICNRG documents describes network coding related stuff. But these documents simply introduce only benefits of applying NC into CCN and NDN. So the purpose of this draft is to describe the sufficient information and the clarification of the requirements and the challenges in order to establish a common understanding about network coding for CCN and NDN. And so we hopefully to provide useful insight to developers who apply network only into CCN and NDN. So here is a proposed structure of this draft. The first, in the introductory section, we briefly introduce the overview of NC and CCN, and introduce current research outcomes regarding network coding for CCN and NDN, and we describe the targeting scope. And after definition of the both network coding and CCN terminology, we briefly describe the background of CCN and NDN, and then in the section 3, we describe the advantages given by NC and CCN and NDN, and then we clarify the requirements. So we will consider how NC network coding can be applied to the CCN and NDN architecture or protocol, and we clarify the requirements. Then finally, after clarifying the requirements, we want to describe the potential challenges for making the communication better using NC technology. So network coding brings some benefits such as throughput capacity improvement and robustness enhancement. So these benefits are not largely, I think, different from CCN and NDN benefits. Network coding focusing on what content to be encoded rather than its data properties, such as where it is generated. So it's very natural to combine them, NC and CCN, to enhance key performance and promote the case for CCN and NDN. So that's why we want to clarify the how we can apply network coding into the CCN and NDN in terms of their network architecture, and then we clarify and describe the challenges for further enhancing these benefits. So I'd like to get into the naming requirements. So because CCN in the CCN and NDN architecture, naming is very, very important. So let me briefly explain about the naming for coded data. So we have two types of about naming. So one is coded data has a unique name or a non-unique name. So by coded data can have a unique name by adding encoding vector and the generation ID like this. In this case, consumer need to know the exactly naming structure to get its for instance, through a specific name resolution system. And in this case, also content request determines encoding vector to be used. That means how these packets should be encoded instead of the content producer. And also, in the case that coded data has doesn't have a unique name, it just indicates that this coded data packet is just a coded data, In this case, coded data may specify the coding information into a metadata field in the payload. And in responding to the...
I just want to ask a clarifying question about the second option where the coding data is in, quote, in the payload. Would that be inside or outside the security envelope?
Yeah, it's a good question, but yeah. I don't have a specific solution. If we add the coding information into the outside payload, it's related to the caching matter. Yeah. So I don't know now of the more much better solution, but yeah.
The reason I ask is which way you do it has, I think, some strong implications for your ability to recode.
Oh, yeah.
Right? Because if it's inside the security envelope, how do you recode without knowing all the keys? Right? Because you're changing something inside the security envelope of the payload.
Oh, yes, yes.
Okay, thanks.
So, and intermediate node would need prior decoding for genetic intermediate coded packet. So next, concerning the transport requirements, we will describe the two aspects. One is we need to discuss network coding scope. So more precisely, we can say it should be discussed that node can update data packets that are being received in the transit, because you know CCNN has a mechanism to validate the data packet. So if intermediate nodes want to recode some data packets, it would require the integrity mechanism to validate the coded packet. And another case, another executes network coding only when the received interest for the coded data can be satisfied. In this case, it's like end-to-end manner, and in this case, it would require a mechanism to ensure full execute and network coding. And we'll describe the basic operation at consumer, router, and publisher, considering how node can provide innovative, useful data coded packet, especially in the case that coded data has no unique name. In this case, consumer would need to issue some interest with some coding information, and the router would need to maintain tally of the interest for a specific name and generation to provide the innovative coded packets in responding to the interest for coded packets. And so in this case, interest doesn't have a unique name, so a router wouldn't need to do interest aggregation to provide several innovative coded packets to consumers, and need to make a specific picture entry to allow the partial matching. So in addition to the naming and transport requirements, we'll describe the requirements regarding in-network caching and security and privacy, and the routing and the forwarding and the seamless mobility. So concerning in-network caching, it may require some mechanism to validate coded packets, so as to avoid cache pollution attack, and router may need to decode and check the reconstruct the original data packet to validate the data packet to be cached. And concerning security and privacy, as I mentioned, network coding impacts the CCNN and security mechanism. So So I think we need to consider two aspects. So one is how intermediate router can modify packets by performing additional network coding operation, and the second is how router can cache the coded data without publisher validation. So it's a key aspect, and we consider routing and forwarding requirement to fully take advantage of energy benefits, and we describe how to achieve the seamless mobility by using a network coding technique and its requirements. So after clarifying the requirements, we'll describe the potential way. Maybe it's not a specific solution, but we want to describe the potential way to fulfill the describe the requirements, and also we want to describe the research items such as how we can adopt sliding or elastic window coding. So most papers regarding network coding for CCN adopts block coding manner when using network coding. But I believe that sliding or elastic window coding makes network coding makes CCN and NDN communication performance more high, much better. So I want to consider this topic, and the rate under congestion control and rating security. So I think the next step is this draft is very preliminary. So we need to improve the draft by having more detailed outline and scenarios. And so there are TBDs. So we need to address TBDs and clarify the requirements and potential challenges in more detail. Thank you very much.
This is Allison Menken again. This is a IRTF question. Where are you're working on this also in in the network coding research group? Do you guys have a sense of, is it reasonable for it to branch into their group and just stay in touch with you, or would you be interested in, because I think that they feel this is actually a really interesting use case for their network coding work.
Did you get the question? Or?
So
I'm
not sure whether you directed the question at him or us.
Both. Yeah. So first I wanted a clarification. Is this work also being worked on in detail in the network coding research group? Because I believe it was. No?
Okay. So it's not we address detailed network coding aspect. It's just use case.
Yeah.
Yeah.
Okay.
So we want to make a draft regarding the network coding useful case for CCN and NDN.
Okay. So the other question is it comfortable to the chairs and this group for a detailed ICN activity to happen over there in the context of, let's see how the coding works and whether it really makes a difference and things like that?
So, I mean, this is going to be a tricky case because there's stuff that's sort of like close to the details of how you do the coding, and there's stuff that's close to the details of how you design the ICN stuff, right? And one of the things that people here know I beat on this all the time is we don't want to assume that some particular ICN architecture like CCN or NDN is immutable, and that anybody who wants to say do network coding on it has to take that as a fixed point and not change anything. So if it turns out in looking at the coding aspects of this, that there's some aspect of the underlying ICN protocol that you choose that really ought to get changed to make it more friendly to network coding, I view that as definitely on the table for ICNRG. Mm-hmm. So I think it's a really hard question to ask as to whether, you know, this is owned by NWCRG with some input from ICNRG, or, you know, owned over here with the coding experts giving their input into us. I mean, my sense is maybe we will need to decide that someday, but for now, I think we'll just cooperate.
Yeah, no, actually, and it's completely an option in IRTF to just cooperate between the two groups. But I just wanted it clear on the table so that, I know what to expect, and also, I assume that some in the group will need to attend both groups, right? So
Yeah.
as long as that's clear, I think that's a very reasonable option to share.
Well, by the way, one of the meta issues that I've been helping deal with is that this area is an IPR minefield.
Yes.
And
we do that.
ICNRG lived in an IPR minefield for quite a number of years, which has now been cleared up. But I think, the experience we've had in this group may help the network coding research group in terms of sort of skirting around some of those things and being able to move this forward in the presence of those kinds of meta issues.
That's an excellent addition to the conversation. Yeah, great. Thank you.
Thank you. Yeah, so we think this is really interesting work, and I mean, you said it's early work, but at the same time, it also really, I think, structures the problem space nicely. So we're looking forward to see more of this in the future. Thank you. Thank you. Okay, so next up is Xia Yong on multi-service tech.
Hello, good morning, everyone. I'm Xiaoyong, and OTT TV services is my area. And okay. Okay. At IETF 99, we talk about technology, and today I will talk about some structure and background. Next. In China, 3 nationwide giant network operators coexist with many small regional networks. And these 3 nationwide giant networks can cover whole country, but small regional network operators can cover some province or cities. And the giant network corporations in network have abundant resources and large-scale users. And in recent years, China OTT TV services subscriber has grown quickly and overtaken traditional TV service. So CDN and cache system are provided for these operators for each content providers. But today, these small regional networks operators encounter more difficulty than before because the video contribute the most of internet traffic. And the invest for CDN and cache system is high, and it become too expensive to afford. And we think what's more, the resource in each regional network are basically the same, and for use scale is small, and the CDN and cache did not make full use. Next. So this picture is show what I want to do, and the blue line is the internet traffic to China Unicom. The China Unicom is a national wide network operators in China, and these 2 circles is 2 province regional network operators. So we want to connect each other, can share their resources. And if we do this, we can reduce the cost of the inter-network segments and improve the efficiency of the CDN and cache systems. Actually, we can connect each other easily, but it's difficult to share content resources because next. Because now we in the existing technology have some limitations. Content share because based on IP address to share content resource is very difficult. For IP is large, is very large, and dynamic and private. So, but if you want to use URL to share content, is very inefficient. Video hosting site use CDN with a range of server to save the same content, but the same content have different URLs. So we can't locate unique content with URL or IPs. So next. So we need a new solution to solve these problems. So we think of ICN is a good solution. ICN can evolve this the internet architecture to directly support information distribution by name data. ICN require unique names for content independently of their location. So we don't need IP. Next. So we give a design of content sharing network based on ICN. According to ICN, we can interconnect regional networks by overlay structure, and regional networks almost use private IP address. In order to sharing content resource, we need name data objects which are location independent. Multi-service tag is designed according to named data objects, and it can be used to scale content resources to share among regional networks. Next. So this picture is the content sharing network constructor, and this constructor consists with two parts. Edge server and control server. Edge server is can interface with local network operators and can make multi-service tags and upload them to the control server and share resources between regional networks. And control servers can receive multi-service tag from each edge servers and schedules resources among edge servers. This picture is something like P2P network. Next. Okay, I give a simple example for multi-service tag design. It's something like URL. And we did some tests in labs and proved tag can work. Next. Thank you for listening.
Thank you. Thanks for bringing this work to us. Are there any questions, clarification perhaps? So I have one.
Okay.
So it seems to me that, I mean, currently you're looking at this from the, say, conceptual perspective. So,
yes.
So what do you need? So what, say, naming information would be relevant for you? So far you haven't considered any specific ICN approach to implement this, right?
Yes.
Okay. So when you say, okay, seeking for suggestions, so are you looking for, advice how that could be implemented, or what is your, what are the open questions for you?
We see many drafts, but we don't know more details about ICN. ICN is what is ICN structure is our problems, and we want to put our solution and ICN structure together, but we don't know details.
Okay. Okay. So that sounds to me like, I mean, so there's somebody who has a specific problem, and so would really benefit from working with people from the ICN community to address those. So we could, I mean, for example, we could have some, discussion on the mailing list, perhaps. So you can people could perhaps come up with some ideas. That would, I think it's a good topic for us to look into.
Okay, thank you.
So when I reviewed this 1 or 2 drafts ago, I think I may have had a misunderstanding, right? So maybe you could clear something up for me. I was viewing the multi-service tag as a separate piece of metadata, independent of the name of the content.
Yes.
And now I look at the draft, and now it's no longer clear because it seems like you're talking about using having a multi-service tag, which is actually the name of the content.
Yes.
So I guess now I'm a little bit confused, right? In other words, if you wanted to take an existing ICN architecture, well, pick the one you want, but they have a naming structure, right?
Yes.
And that's how you would name the content. What I'm trying to understand that you're trying to do here is, it's knowing the names is insufficient in the application you're talking about to decide which of these regional networks should cache that content, which of them should source that content, which of them should do that. So it would be nice to have an independent piece of metadata that is managed by a centralized authority that says, hey, this regional network ought to be caching and requesting this content. This regional network is or ought to be the source of this content, right?
Yes.
And in order to do that, you need some kind of scheme for designing these tags.
Yes.
Right?
Yes.
Okay, now I think I understand it better. Thank you.
Yes.
Other questions? All right. Thank you very much. So that brings us to the end of the program for today. So just a couple of things. So we are planning to have another ICNRG meeting at the next IETF in London. We haven't really made up our minds whether there's going to be a full Sunday meeting again, but we could certainly do it. Please talk to us if you have some suggestions, maybe on topics and so on. So would be interested to meet again in London. Not all at once. Okay, I take this as you have to think about it. Okay, so one other thing. So we often sometimes we had interims, say at the beginning of the year. So in January. So maybe one in Paris, one in Boston. So we thought about that could be something to do again in January. So would make sense most if we could find some specific topic area to focus on. And so we didn't have time to really come up with proposals. So if you have ideas, IoT, edge computing, whatever, we could talk about it. We would need a host and a good location. So we'd be open to organize something. Anything else we have to say?
I'd like to weigh in on this. There isn't a lot of time between now and a January interim. And in the previous times we've done this, it's worked because we had a large backlog of stuff, right, that just didn't get through. I don't, at the moment, well, sort of half chair, half personal. I don't see a lot of backlog where we have a whole lot of things that people have done work and it just hasn't gotten the chance to get discussed. So if people want to have an interim meeting, my suggestion is somebody should stand up and say, I want to help organize a meeting around topic X, and I'll take the lead, because the chairs have been doing all this organizing work to sort of push various topics forward, and that's been okay. But we'd like more active sort of help in moving given topics forward with leaders. I mean, Junge has been a great leader for the NRS work. There are other areas where I think it would be really helpful if people stepped up and said, I'm going to help drive the discussion and and the organization of getting people to contribute to, area X. If we don't hear that, I think we don't have much time to organize an interim meeting between now and London. So it would have to happen relatively quickly. I didn't clear that with my co-chairs before I said it, by the way, which might have not been great.
Okay, unless there are any other comments, any other business, thank you all for coming and see you soon.
We have one more blue sheet thing. Do you have the blue sheet? Anyone see the other blue sheet down there somewhere? Well, large point of the is fine. We can just say,
around the same standard they started around, but it makes
well, we might want to send out a note saying, look, we want to engage this territory in terms of standards. Anyone else to sign this? Well, they can also anywhere they like. So I'll be in NWC or not. They wind up putting them in some way.
Hi Dave, I wanted to pick up on the discussion on Sunday. I mean, not the one that, not the other one. I mean, you brought up the point that the state of profession that could be somehow related to it.
Well, this is if you do anything that isn't pump by pump.
Yeah. I was just
decided to do some kind of compression that goes multi-pump. Yeah. Right. I mean, somebody was saying that it's really expensive to decompress and recompress these little boxes in every box. And I think we need to actually measure